Good day everyone, this is Mr. Brian Bulactin again at your service. I am back for another tutorial video in Mathematics 10. Today, I'll be talking about solving polygons. So we will stop here because we are just given n is equal to 7. So we will start with 3. Three factorial. 7 minus 3 is 4 factorial plus you have 7 factorial over 4 factorial. Then 3 factorial will be expanded. This will become 3 times 2. Now let's move on to the third combination. Plus 7 factorial becomes 7 times 6 times 5 factorial over, you copy 5 factorial. Then 2 factorial is 2 times 1. So you may not the numerator. The denominators or the factors in the denominator are already cancelled. So let's proceed to the second combination. 4 factorial can be cancelled. Then 3 times 2 is 6. Cancel. Then 6. Now let's proceed to the third combination. 5 factorial can be cancelled. Then we have 2 here. And 6 can be divided by 2. 6 divided by 2 is 3. So 2 will be cancelled, while 6 will become 3. Let me just write it properly or clearly. your 6 becomes 3. Okay, now let's proceed to the fourth one. Cancel 6 factorial. And then 7 factorial can be cancelled also. So proceed to writing the remaining factors in the numerator. So for the first combination, you have 7 times 5. For the second combination, you have again 7 times 5. So these are the remaining factors in every combination. Now proceed to the third one. You have 7 times 3. Then for the fourth one, you have 7 plus the fifth one, cancelled, right? So the operation is division, therefore what is left is 1. So 7 factorial divided by 7 factorial is equal to 1. So you have to be very careful with this. If it is addition or subtraction, when you cancel quantities, the result is 0. But if it is division, when you cancel quantities, the result is 1. Okay, let's continue. 7 times 5 is 35. Then plus 7 times 5 is 35. Plus 7 times 3 is 21. Copy plus 7, then plus 1. So this is equal to, so I'm going to explain this, that 35 is the number of triangles that we can form given 7 distinct points. Then 35 4-sided polygons, 21 5-sided polygons, 7 6-sided polygons, and 1 7-sided polygon. The question was, how many different polygons can be formed given the 7 distinct points? So, to answer the question, you need make 3 combinations for the 3 groups. For this, you can have combination of 5 taken 2. For the other group, you can have the combination of 7 taken 2. And for the third group, you can have the combination of 6 taken 2. Now the next question is, what will be the operation to use in between the combinations? Are we going to use addition, times, copy your n, 6 factorial over r 2 factorial. 6 minus 2 is 4 factorial. Now let us simplify it further by expanding the factorials. So 5 factorial becomes 5 times 4 times 3 factorial. So I stop becomes 3. So since we don't have the luxury of the space, because we are just using a small whiteboard, I have just erased the writings on the upper portion of this to give space for the next steps. So I will just, this step will be continued here. Again, we will be writing down the remaining factors in every combination. So in the first combination, the remaining factors are 5 and 2. Then you have copy the multiplication symbol. In the second combination, you have 7 times 3. And on the third combination, you have 3 times 5. Now you proceed to multiplication. 5 times 2 is 10 times 7 times 3 is 21 times 3 times 5 is 15. Now, to get a total number of 6 balls, you're going to multiply everything. So 10 times 21 times 15 is equal to 3,150. So there are 3,150 different ways of forming a group of 6 balls in which there are 2 balls from every color. So there are 10 different ways that you can choose 2 red balls from the group. Then 21 ways of getting 2 green balls from the green group, and 15 different ways of choosing or getting 2 yellow balls from the yellow group, and a total of 3,150 different ways of selecting 6 balls in which there are 2 from every color. Let's proceed to number 3. From 7 biology books and 6 chemistry books, in how many ways can one select 2 biology and 2 chemistry books to buy if all the said So you have the word "and", meaning it's not optional. He or she needs to get 2 from biology and 2 from chemistry. So he needs to perform the 2 activities. Therefore, you are going to write the operation multiplication. Okay? So to simplify it further, applying the formula, this becomes 7 factorial over your r, 2 factorial. 7 minus 2 is 5 factorial. Then times, copy your n, 6 factorial over 2 factorial. 6 minus 2 is 4 factorial. And to simplify it further, you're going to extend the factorials. And this becomes 7 times 6 times 5 factorial over 2 factorial is 2 times 1, and that is equal to 2. Then copy 5 factorial. Copy the multiplication symbol. 6 factorial becomes 6 times 5 times 4 factorial over 2 factorial is 2 times 1 equals 2. So you copy 2, then copy 4 factorial. Now cancel. Cancel the common quantities. So for the first combination, you can cancel 5 factorial. 6 divided by 2 is 3. So cancel 2. 6 becomes, your 6 becomes 3. I'll just write a small number 3 here. Hopefully you see it clearly. So your 6 becomes 3. Then, for the second combination, you can cancel the 4 factorial. Then 6 divided by 2 is 3. So 6 becomes 3, and then 2 is cancelled. Now proceed to writing the remaining factors. So let me just write the continuation here. Okay, so for the first combination, the remaining factors are 7 and 3. Copy the multiplication symbol. Then for the second combination, the remaining factors are 3 and 5. Simplify. 7 times 3 is 21 times 3 times 5 is 15. You get a total of 315. So, he or she has 315 ways of selecting 2 biology books and 2 chemistry books. Number 4. In a dance contest, each participating group must perform 3 kinds of dance. If there are 4 choices for ballroom dance, 8 choices for foreign dance, and 5 choices for hip-hop, in how many possible ways can a dance group select their piece? That means they need to choose one from the 3 different choices or 3 kinds of dance. So the first kind of dance is ballroom dance. So you have 4 choices for the ballroom. And the dance group has 8 choices for the foreign. Meaning, choosing one from ballroom alone will not satisfy the problem because they need to get really one from different groups. So, having said that, the operation to use is multiplication. Multiplication ang gagamitin dahil kailangan nilang pumili ng isa sa bawat klase ng sayaw na meron. So, pag ganyan, multiplication ang gagamitin. Hindi ka gagamit ng plus. Kasi pag gagamit ka ng plus, parang sinasabi mo na enough na napipili lang sila sa ballroom. Hindi na kailangan pumili pa sa foreign, hindi na kailangan pumili pa sa hip-hop. Kailangan nilang pumili ng isa sa bawat klase ng sayaw to satisfy the problem. So, we are now ready to solve. Applying the formula, this becomes 4 factorial over 1 factorial. 4 minus 1 is 3 factorial. Kopyahin mo yung multiplication. Dadako naman tayo sa pangalawang combination. Magiging 8 factorial over, kopyahin ang 1 factorial. 8 minus 1, 7 factorial. Then times, kopyahin mo yung n. So that is 5 factorial over 1 factorial. 5 minus 1 is 4 factorial. So, to simplify it further, you need to extend the factorials. And 4 factorial becomes 4 times 3 factorial over 1 factorial. 1 factorial is 1. So you may not write 1. Then copy 3 factorial. Wala na yung 1 kasi any number multiplied to 1 is equal to itself. So if pwedeng, hindi mo na isulat yung 1. Then times 8 factorial becomes 8 times 7 factorial over 1 factorial is 1, so you may not write it, then copy 7 factorial. To number 5, the question goes, if 3 marbles are picked randomly from a jar containing 6 red marbles and 8 green marbles, In how many possible ways can it happen? And if he can have 3 greens, is he going to get from red? The answer is no. He will not anymore get from red. It is because he or she needs 3 balls only. So let me state it again. If he or she will choose 2 from green, he or she needs 1 from red because he needs to get a total of 3 balls. Since the condition states that at least 2 of the marbles picked are green, it means he or she can have 3 greens. And if he or she will have 3 greens, he doesn't need red anymore. Only 3 balls are needed. So this is our second situation. Okay? So let us solve first the first situation. So for the first situation, you can have the combination of 6 taken 1 times, it is multiplication because he needs to perform the 2 tasks to satisfy the problem. Then times combination of 8 taken 2. So this will be the solution for the first situation. For the second situation, you can have combination of 6 taken 0 times the combination of 8 taken 3. So we have 2 sets of solutions. So this is for the first situation and this is for the second situation. This first situation has nothing to do with the second. So, to get the total number of possible ways, you are going to get the sum 4. So 2 is cancelled, while 8 becomes 4. Write the remaining factors. So for the first combination, you have 6, and times the remaining factors in the second combination are 4 times 7. So that is 6 times 4 times 7 is 28. So you have 6 times 28. So you'll have 6 times 28 is equal to 168. So that is for the first situation. We are not yet done because we still need to solve for the second situation. So there are 168 ways that he or she can choose 2 green marbles from 8 green marbles and 1 red marble from 6 red marbles. So there are 168 different ways. But are we done? Is it enough to answer the question? The answer to that is no. We're not yet over. We still need to solve for the second situation. So since we don't have the space, the luxury of the space, please allow me to erase the solutions here. And I will just write the final answer. So the result of this combination is 168. Okay? And I have already shown you the solution for that. So this time, let us solve for the combination of 6 taken 0 times the combination of 8 taken 3. So this is equal to, applying the formula of combination, this is equal to 6 factorial over 0 factorial. Then 6 minus 0 is 6 factorial times, copy, 8 factorial over 3 factorial. 8 minus 3 is 5 factorial. Answer the question. So, you get the sum, the 2. You'll have 14, carry 1. 11 plus 1 is 12, carry 1. Then 2. So the answer is 224. There's a total of 224 possible ways that he or she can choose or select 3 marbles randomly from a jar containing 6 red marbles and 8 green marbles if at least 2 of the marbles picked are green. The problems that we had a while ago were actually additional examples for combination. So our main topic is solving problems involving permutation and combination. And I'm going to show you a problem wherein permutation and combination are in one problem. So take a look at this.